Power series. Definition of a power series. If x is a variable, then an infinite series of the form summation of a sub n times x to the power of n is equal to a sub o plus a sub 1x plus a sub 2x squared plus a cube x cube plus the and so on. It is called a power series. More generally, an infinite series of the form summation of a sub n times the quantity of x minus c to the power of n as n approaches to 0 is equal to a to the plus a sub 1 times the quantity of x minus c plus a sub 2 times the quantity of x minus 2 squared plus so on and so forth. So, where c is a constant. An important function f of x is equal to a to the power of x can be represented exactly by an infinite series called a power series. For example, the power series representation for a to the power of x is a x plus 1 is equal to 1 plus x squared over x or 2 factorial plus x cubed over 3 factorial and so on. So for each real number x, it can be shown that the infinite series on the right converges to the number a to the power of x. So like for example, the following series is centered at 0. So we have here the summation of x to the power of n over n factorial when n is equal to 0. So I have here 1 plus x to the power of 2 over 2 plus x to the power of 3 over 3 factorial and so on. Another example, the following power series is centered at negative 1. So, summation of quantity of negative 1 to the power of n times the quantity of x plus 1 to the power of n when n is equal to 0. So, we have here 1 minus x plus 1 plus x plus 1 squared minus x plus 1 cubed plus so on and so forth. Then, the following series is centered at 1. So, we have here summation of 1 over n times the quantity of x minus 1 to the power of n is, as n is equal to 1. So we have here x minus 1 square quantity of x minus 1 plus 1 half times the quantity of x minus 1 squared plus 1/3 times the quantity of x minus 1 cubed and so on. So radius and interval of convergence. So a power series in x can be viewed as a function of x or is equal to f of x is equal to summation of a sub n times the quantity of x minus c to the power of n where n is equal to 0. So when the domain of f is the set of all x for which the power series converges, of course, every power series converges at its center c because f of c is equal to summation of a sub n times the quantity of c minus c to the power of n when n is equal to 0. So we have here a sub 0 times the quantity of 1 plus 0 plus 0 plus 0 plus so on. So a is equal to a is 0. So c is always lies in the domain of f, like the theorem 920. So a single point. So dari ata sa convergence of a power series. So for power series centered at c, precisely one of the following is true. So the series converges only at c, then there exist a real numbers when r is greater than 0 such that the series converges absolutely for x minus c when it is less than real numbers, and it is diverges for x minus c when r is greater. So the series converges absolutely for all x. So the number r is the radius of convergence of the power series. So if the series converges only at c, then the radius of convergence is r is equal to 0. If the series converges for all x, then the radius of convergence is equal to positive infinity. So the set of all values of x for which the power series converges is the interval of convergence or if a power series. So, like for example here, finding the radius of convergence. So, find the radius of convergence. Summation of n factorial x to the power of n when n is equal to 0. So, the solution is 4x. So, we have here f of 0 is equal to summation of n factorial, then 0 to the power of n when n is equal to 0. So, it is equal to 1 plus 0 plus 1 plus and so on is equal to 1 lang yapon siya. So, the radius of convergence of this equation is 1. So, for any fixed value of x such that absolute value of x is greater than 0, so let u sub n is equal to n factorial xn. So, limit of u, absolute value of un plus 1 over u to the u sub n when n is approaches to infinity. So, limit of the absolute value of n plus 1 factor times the quantity x to the power of n plus 1 is equal to absolute value of x greater than 0. So, then it is equal to absolute value of x limit of n plus 1 as n approaches to infinity. So, the answer is infinity lang gyapon siya. So, for example number 2, therefore by the ratio test, so the series diverges for absolute value of x is less than or greater than 0 and converges only at its center 0. So, the radius of convergence is equal to 0. So, thank you for watching.